Hello everybody, this is Chris Knutson again with Yaskawa. We're doing a Sigma SD launch webinar here today. The Sigma SD is a spindle motor and drive combination. So today we'll have some introduction. We'll go over a couple of key application terms that are related to spindle motors and drives. We'll talk a little bit about the differences between a spindle and an inverter, some of the features and benefits of Sigma SD, slides on the system overview. We'll talk about target machines, short discussion on competition, some of the sales tools that are available and the support, and then we'll have a Q&A session. So a spindle is the rotary axis on a mill driving the tool, or the rotary axis on a lathe driving the workpiece. And what I'm showing on the screen is a horizontal milling machine or horizontal machining center. And it shows the spindle motor right here with a tool directly attached to it. That's not actually the way we typically see a configuration in the industry. This is just a picture I found off a website. Typically what you have is a belt drive between the spindle motor and the spindle mechanical section. So there's a mechanical portion of the spindle which I have viewed here in the bottom right of the presentation. The spindle drives, Sigma SD drive, consists of both a regen converter and an amplifier. You can see that on the bottom toward the left of the picture. There's on the left side is the converter, and the right side is the Sigma SD spindle drive. I'll show you a quick presentation view of what the belt drive arrangement would look like. Here's the spindle motor with the belt drive, and then the mechanical section where we'd have a chuck holding the tool. And this is an actual picture of one of our customers' machines. You can see with the right hand view, the spindle motor toward the top of the machine, the upper right, and then a big white section where you have the belt drive, and then coming down to the bottom you'll see the spindle mechanical section. To the left up here is a tool changing mechanism, which we'll talk about in the next slide. Some application terms. Gain switching. So the Sigma SD has three sections of gains, one for doing what we call spindle orient, one for rigid tap, and one for cutting. We call all those gains related to one type of operation, bank of gains. And so the spindle allows easy changing between the gains on the fly, either over selecting the gains over I/O or by commands over EtherCAT. So this is a standard feature that allows for spindle orient and rigid tapping. Spindle orient is when you position the mechanical spindle to align with the tool changer. And you can see the picture in the upper right. The tool changer is what's on the bottom there. And you typically have to rotate the spindle and position the spindle in order to pick up a new tool. So spindle orient, you have to be going low speeds, typically 300 to 500 RPM, and you have to actually servo to a position. Rigid tap is another feature that's used in cutting metal, and in this case you're tapping a hole by synchronizing the z-axis position, or the feed, with the position and velocity of the spindle rotation. And you can see a typical cutting tool right there. In order to have that cutting tool cut through a spline motion, you have to have that feed direction synchronized with the tool rotation. Again, you have almost a servo mode of operation here. The older method used a flexible tension compression tap holder, and that's why we get the term rigid tapping. Rigid tapping is done in the 1,000 RPM range, and again needs that servo mode that we have on a spindle. So spindle is in in between, performance-wise, in between a inverter and a servo, and it's meant to have high power and a wide constant power range. So the differences, a little bit of a difference here I'm going to show of inverter versus a spindle. If I were to combine a standard AC induction motor with an inverter, you'd get a base speed of 1750 RPM, a max speed of 3500. The peak torque would depend on the class of the motor being used, the NEMA class. You wouldn't know exactly what your torques were. You'd have to calculate those. If you use the network drive, you may get a network update rate of 1 millisecond, and you would pretty much only have velocity control. When you use a spindle motor, like a Sigma SD, and I'm showing a 15 kilowatt rated motor picture to the right, we'd have a 1500 RPM base speed, 7000 RPM max speed, with some models going to 10,000 RPM. This high speed is used for surface finish cutting on a block of metal. Peak torque, you'd have 200% continuous torque for 10 seconds, and that usually is quite a bit longer than you would have with an inverter. And you can see the network update of a drive is 250 microseconds now versus 1 millisecond, so 4 times faster on the network update. The bandwidth of the Sigma SD is not published, but it's quite a bit higher bandwidth than an inverter. Maybe not quite as high as a Sigma 7. The drive motor performance is published. You can see this is the diagram shows the kilowatt versus the motor speed, and this is right out of the catalog. And finally, you have velocity and position control. Some of the features and benefits, as we mentioned before, if you look at the drive, it's actually 2 units. To the left is what we call a converter. It takes in AC power and produces DC power for the amplifier. This converter can regen the energy, take the regen energy and put it back onto the line. So in any type of metal cutting operation, you're typically having to go through cycles and grab new tools and then go through another cutting cycle. Whenever you have to decelerate the whole load and the tool and the spindle mechanism down to 0 speed, it's a lot of regen energy, and putting that onto the line saves in heat and reduces energy consumption. Again, we mentioned the high bandwidth drive of the motor. It's a low inertia motor compared to an AC induction motor, so it can respond quickly to commands. It has a servo-like performance and produces smooth finishes at high cycle rates. Again, another key thing here is you have torque at 0 speed, which makes it quite a bit different from an inverter. The actual motor technology used in the Sigma SD motor is an AC induction type of technology, so it's a asynchronous servo. It's not a permanent magnet. But with the vector technology that we have in the Sigma SD drive, we're able to get that 0 speed torque. And we have open network protocols here. We've got either an analog interface, or we can use EtherCAT with the CAN over EtherCAT 402 drive profile. Moving on to the system overview. If we look in the catalog, the spindles are rated for 50% duty cycle. So 50% of the time, or 5 minutes, we're running, 5 minutes we're stopped. And this is something that's come out over the years. It's called 50% ED in some cases, as you can see on the diagram. The continuous rating of a spindle is one size down. So a 15 kilowatt rated is actually 11 kilowatt continuous. So as you can see here, I have a UAKAJ 15C. 15 is the rated power for a 50% duty cycle. It has a 11 kilowatt continuous rating. And this, of course, works only in combination, a Sigma SD drive with a Sigma SD motor, and that's how we sell them, only as combinations. Moving on to the part numbers. The spindle motor offering in 200 volts goes from 3.7 kilowatts to 45 kilowatts. If you think about spindles, the real sweet spot of a spindle is somewhere between 7.5 kilowatts to 22 kilowatts. 200 volts is still very popular in the machine tool world. 400 volts is getting more popular. So we have 3.7 kilowatts to 22 kilowatt available in the 400 volt. Right now, as of the publishing of the webinar, the motors are not UL listed. We're working on getting those listed, and that may produce a letter design revision letter part number change. But we are able to offer the drives as UL recognized, and these are fully CE in conformance with CE. So an example of the 200 volt AC 22 kilowatt rated standard motor would be a UAKAJ-22CZ1. So I think when we look at the part numbers in the catalog, the easiest way to find out what is a standard motor that's more readily available is to use our online price tool, which you would go to our website, log in, and select the power, the voltage, and the interface, and you'd get a complete bill of material. There are some options that we're not launching. Example would be a UAK BJ. The B would be a dual winding motor. Those are heavy duty, high weight motors that take up a lot of dollars of inventory. So we're starting out the launch with our single winding flange mount motors. And as you can see, an example of a 400 volt, 22 kilowatt rated standard motor is a UAK-AJ 22CZ100E. The spindle drives are offered in the same power ranges as the spindle motors. The option that's most important here to choose is the voltage and the interface, whether it's analog or EtherCAT. So I have shown here an example of a 200 volt AC 22 kilowatt rated analog drive. That's a CACR JU102AEAB. And the example of a 400 volt AC 22 kilowatt rated EtherCAT drive, I should say, not a motor, I've got a typo, would be a JU051ACAB. So you can see the drives are rated by current, not by power, and the current goes down as I go up higher in voltage. The converter is offered in 200 and 400 volts. The converter starts at 15 kilowatts and goes up. So that gives us a larger converter in the cases when you're using when you want to do a small spindle. So the reason behind that is this spindle is really made for the sweet spot of spindle applications, which run from about 11 kilowatt to 22 kilowatt. If you go to a very small size spindle motor, it won't be as competitive as an offering because we start at 15 kilowatt with the converter. You also can choose then between 200 volts and 400 volts and the size, and you're pretty much done with selecting the converter. Moving on with the system configuration, there are some other components that are important. If we've got a selection chart showing the motor, allows you to choose the power regen converter model, the servo pack model. There's also an AC reactor. We're putting the energy from the regen back on the line. We need to add some impedance between the converter and the line, so an AC reactor is required. And then I'm showing stock status in the brochure and the technical supplement. And the products that we have stocked are only limited stock, so 1 to 2 units per part number. The Sigma SD is very much set just for the machine tool world. We're looking at retrofits and prototypes. Prototypes with an OEM, a machine builder that is going to do repeat builds, need to be forecasted with us. Otherwise, we're going to have stock issues. So when we say limited stock, we just have a couple units in stock for doing prototypes and some for retrofits. We don't have a big forecast in place for this line. We'll have to ramp up with it as sales ramps up. So stick with the limited stock models, and they go from 7.5 kilowatt to 30 kilowatt in the 200 volt, and from 7.5 kilowatts to 22 kilowatt in the 400 volt. Cables, reactors, line filters, all the accessories, everything to put together a bill of material are detailed out in the Sigma SD technical supplement, which is on the web. You'll see the only kind of difference, there's some extra cables that go between the converter and the amplifier. That's the difference between a normal servo. And then as far as the motors go, they have terminals, so there's no power cable, no typical power cable that we would offer for a servo that has its connectors on one side. You just use a standard raw power cable and wire it into the terminals. Everything for a bill of material, as I said before, is best to be found on our online price tool. Commissioning a Sigma SD drive can be done with SigmaWin version 5.75, and I'll show where we talk about that on the website. But so it has to be the SigmaWin version 5.75 for using Sigma SD. There's something called a component installer that you have to run, and then you'll get this view that says Sigma 5 SD. And this brings up kind of another note. The Sigma SD is built off of the Sigma 5 base drive firmware, so their parameters are similar to a Sigma 5 servo drive. They're not all the same number, but you'll find a lot of similarities in setting up Sigma SD versus a Sigma 5 drive. And of course, a handheld digital operator can be used. The same handheld digital operator for the servo works for the Sigma SD. Some of the target machines, these are all metal cutting machines in the machine tools segment. Lathes, mills, turning centers like a vertical or horizontal machining center, boring mills, coping machines. A coping machine is a machine that cuts slots and holes on beams. We actually have an OEM today that uses these for drilling the holes on the beams. Drilling machines, as I mentioned. A couple machines that are not targets that have specialty high-speed spindle motors are routers and grinders. Routers start at about 20,000 RPM, and grinders can go even much higher than that. So these spindles are traditional metal cutting machines that go up to about 10,000 RPM max. So the competition kind of depends on the space that you're operating in. If it's a retrofit, inverters are commonly used in order to use an existing motor, and they're inexpensive. A lot of retrofits have a very tight budget. Inverters do sacrifice speed regulation, and bandwidth. They often require extra engineering to accomplish a spindle orient, and they're often too coarse of a speed regulation at low speed to do rigid tapping. So those are some of the Yaskawa strengths, that we can do a better job on rigid tap and spindle orient and higher speed regulation. On new installations, you would be competing against a Fanuc, a Siemens, or a Mitsubishi. And those competitors sell spindles as part of a closed architecture system where the spindle is connected to the CNC through a proprietary network protocol. So only a Fanuc CNC would work with a Fanuc spindle. In a lot of cases, what we've seen now is companies that want to have third-party CNCs, and I've listed a few of them that we've worked with. Centroid is one, Mach Motion is another, Power Automation is a third. Or they do controls in-house. They want to have an open connection to their spindle. So the Sigma SD is one of the only spindles in the market that has an EtherCAT open network interface. Sales tools, the launch PowerPoint is on the website. There'll be a brochure that is in the same format of our Sigma 7 and Sigma 5 brochures, and motion brochures, technical supplement, which is a catalog that has a heavy dose of specifications in it. We've got the product page on the Yaskawa.com website, and all the systems that I talked about, all the components are part of the online price tool. Again, as far as the online price tool goes, it's a very easy selection. You select the power, the voltage, and the interface, whether it's analog or EtherCAT, and you get a complete bill of material. As far as support goes, some of our standard support tools you'll recognize here: 1-800-YASKAWA tech support. We do have a lot of M5 legacy spindles in place already in the field, installed through OEMs in the machine tool market. So we do have a group that's very familiar with spindle applications inside Yaskawa on the phones. RMEs for pre-sale support of new OEMs. Aftermarket service is available to do installation or commissioning. And then as far as retrofits of legacy Yaskawa goes, we do want to route those through service orders with our aftermarket group. MT2, MT3, VM3 are very common older spindles that are out in the market that you can get credit for sales for retrofits. But we like to do that as a time and material retrofit system quotation in order for it to be fast and efficient. And then M5 was the most recent spindle that we had that was sold, that the Sigma SD is now replacing that also. So you can also contact the factory for special quotes for repeat business, motors that have modified torque speed curves. When I say repeat business, this would be a new OEM that is building a machine that they're going to build multiple units of. Dual winding motors are available, and we have a process called a special product request. You can work with your Yaskawa outside sales rep to handle those. So some of the Q&A, we'll run through some Q&A. We'll look at the product web page. We'll look at the online price tool if I can get everything to work right. And then we'll cover some of the Q&A that has come in from the question log of the webinar. So can the Sigma SD run a legacy Yaskawa spindle motor? In many cases, yes, if it was from the MT2, MT3, VM3, or M5 series. Check with service for a time and material retrofit quotation. So I'll just use an MT2 as an example here. There are some products that service has that are not set up to be sold as new products. You can contact our service group and work through a service order. One example in an MT2 was the older motors used a resolver, and they've got a resolver to encoder converter kit that can be sold, and that's best done through our aftermarket service group then. But the answer is yes. There a lot of cases in the systems that are out there, that are out in the field today, the motor is usually good, but the drive will be the thing that fails first. So an MT2, MT3, VM3, these are probably 25-year-old products that are open for replacing. Can the SD run another manufacturer's spindle motor? So I've got a long answer here. Like our servos, Yaskawa tests all the combinations of the spindle drives and motors as part of our quality policy, allowing fast installation and startup in reference to a published performance curve. Running a third-party spindle motor requires us to do testing, which would make it uneconomical unless volume is high. So we're looking for systems where we can sell our servo, the Sigma SD, with the Sigma SD amplifier, the motor and the amplifier together as a combination. If you get in a situation where somebody really needs a third-party motor, that's something that we have to do a special product request on. What is Yaskawa's repair policy for Sigma SD? Yaskawa will maintain one unit in stock for repair exchange if a unit goes down. So we're doing an exchange. We don't have the capability to repair the items here in the U.S. at this time. We're working on getting that, but right now we're going to be exchanging product from stock So critical installations should have a spare. What is the lead time if a unit is not in stock? So we have limited stock launch that we're talking about here. So we'll have 2 units in stock besides the refurbished stock that we'll have for exchange. If we're out of stock and in the process of reordering from our factory, then the worst case lead time is 16 weeks. What is the factory warranty? We've got a standard 18-month warranty that's on our standard terms and conditions. Extended warranties can be purchased. And right now I'm going to take you to the Yaskawa webpage. This is the Yaskawa.com site. We go under products, motion, and all the way to the right here we've got Spindle products. These are motion products. Sigma SD based on Sigma 5 is a motion product, and everybody on the line should be a motion channel, part of the motion channel, or a Yaskawa associate. So let's look at Spindle SD drive first. Sigma SD spindle drive first. And we have a typical product page. Under overview, you'll see some of the features, model ratings. If you want to quickly know what a standard model is with some of the features, what the voltage is, what the power is, and the interface, you can scroll down this tab. So a 200 volt EtherCAT with a 15 kilowatt rated power or 11 kilowatt continuous. You can get a part number. And then the model number key. That was shown in the webinar. You'll see a brochure and a technical supplement document available. Under software, this is important that we use the Sigma Win Plus version 5, or actually it will end up being version 5.75. There is a component installer software. Sigma Win Plus communications component for Sigma SD. This is software you have to run in order to get communications to the drive. There's a technical document that walks you through using screenshots on how to do that. And then there's motor parameter files for each of the Sigma SD motors, also right here, that you can download to set up a particular motor drive system. Under documents, you'll see manuals, CE certifications, and the sales literature. And under drawings, we've got 2D drawings that are in PDF only at this point. We're working on getting CAD drawings, but the thing we're working on mostly is filling out our inventory here of solid model drawings. So certain models that are popular sizes and an interface that we've already sold in the market prior to launch, we've had solid models of. So everything's on the website. Our website, unfortunately, doesn't have a great search engine, so I'm showing you the best way to browse around to the details. Browsing is the best way to go. And now what I'll quick show you is the online price tool. You have to log into the Yaskawa.com. And then go to Partner Home under I just had this price books and price changes. And then under Motion, online price tool, log into the price tool, And now you'll see at the bottom here on the right, Sigma SD spindle axis. Let me go to customize. Maybe I'm just not, maybe I've got a user error. Here we go, got it. So select the power. I'm going to select the 22 kilowatt that I've talked about today. Select the power, 200 volts. Select an interface. I'll go with an EtherCAT interface. The encoder is a pulse encoder. That's always there. Line filter, no option selected. Typically you only would need a line filter for a CE installation that's going to Europe. Flange type is flange mounted. Mounting type is flange instead of foot mount. We haven't launched the foot mount. And then single winding. So you can see the status on the right here is complete. I've got a complete system. And it'd be nice to sell a lot of these because the list price is $15,000. And we've seen that this has been competitive between 10 and 22 kilowatts in the marketplace. So with that, we'll open up some of the questions that came in on the webinar section. We do have a pretty new product here. We haven't launched spindles to the market, so hopefully we've got some good questions from you guys. Well, the first one is, does 50% duty cycle have a maximum of 5 minutes on? So I've got Bill Liang here from engineering to answer some of these questions. The 50% duty cycle is a rating of 5 minutes on and 5 minutes off. I wouldn't say it's a maximum on for the product. Bill, what would you?
In most applications, 5 minutes is a long time on, on the spindle.
Right.
And so, typically that's why we rate it at 5 minutes on and 5 minutes off. Okay. So that's how we classify it as 50% duty cycle.
You certainly can run it for more than 5 minutes.
But you need to stay off for that length of time.
Another way to look at it would be the continuous power rating. If you're doing calculations on the power required, then you can go back to the continuous power rating and think of it like a servo. But most of these applications, the user or the machine builder will give you a power rating of the size spindle that they need. And a lot of times the machine specs are built around the spindle instead of the other way around. Okay, the next one here. In order to regen back to the line, the drive needs to be powered by DC. When powered by AC, how is regen handled? Is a resistor required?
There is two components for the SD spindle drive. One is the converter, which converts the AC into DC, and then the servo pack, which is running on DC from the converter. So if you don't want to use the converter, you want to supply your own DC, you have to handle regen yourself. Okay, so it's a combination. The recommendation is use a package, as Chris has mentioned before. You get this SD system, which you will get the converter and the servo pack and the motor. Right? That's the way to do it.
Right. So I think the question probably stems from the fact that our Sigma 5 drives, if you wanted to do regen back to the line, you would put DC into the drive and then you'd have a DC power supply. That's not the case here. We've got the converter taking care of everything for us. And there's actually communication between the converter and the amplifier, so we wouldn't recommend straying off of that combination. Does the Spindle Sigma SD motors have mechanical compatibility with the previous spindle generations?
Yes.
Yes, it does. It has the same flange and the same pilot and the same shaft size. And that would be an M5 spindle motor. IP44 is a standard IP rating for the motor. Can a single converter run multiple drives? It is possible. We haven't launched the system that way.
Yeah, right now we don't recommend
Right now, we don't recommend it, but if it's a volume application that we need to look into, we can do that.
There's a question about orientation. Spindle orientation is handled by the drive. What you need to do is you have to send in a signal called the ORT signal. When the drive receives that signal, it will go into the orientation routine and slow down to the orientation speed and look for the marker pulse and come to a stop at some offset to the marker pulse that is predetermined by the program or by the user.
And that brings up another point on training. We did an internal training session on Sigma SD. We're working on having an e-learning module as the next set of training, and then we'll be judging each application on the complexity and determining our plan for future training based on that. Part of it, of course, will be centered around doing details on orientation. Yeah, the literature is available. The brochure and the technical supplement are on the literature request form, and they can be ordered as hard copies. Another question about the availability of an e-learning module. We're working on that right now, and before that time, work with your RMEs for new applications and aftermarket service if there's a legacy system installed.
The resolution of the encode is 1024.
Limited stock is available right now. You can check on lead times. The 1 or 2 units are in stock right away for ordering right now. Size of units, a typical 15 kilowatt motor, or actually was it 22? A 22 kilowatt motor would be 9-inch square flange, to give you an idea. We've talked quite a bit about the 22 kilowatt motor.
Yeah, 15 is 9.
230 millimeter square. So yeah, it's typical with the industry. The sizes are in line with other competitors in the market. Some of the other questions here have to do with retrofits. We're going to have to get back to people individually on that. We're thankful for all the questions. I think we've covered most of everything today. Bill's got one more.
One question was about single-phase operation. We do not operate in single-phase. It must be three-phase.
Must be three-phase. So with that, we're going to call it a good webinar. Thank you guys, everybody, for coming. We'll have this webinar recording posted to the websites very soon, and we'll be doing follow-up with some of the questions that have to do with specific retrofits one-on-one. So thank you, everybody.